CTO CMO, so we're our host today. Very excited about this meetup. First of all, very excited to work again with a Hive. Always great conversations that come from those events. But even more excited by the theme of today, data science. For those who may not know about TIBCO, we're all about connecting intelligence in businesses, helping businesses connecting to that data, and creating a data ecosystem, and then driving understanding with the right actions, with the right decisions in the hands of the right people. That's what we call connecting intelligence, what we've been doing for 20 years. And we work in collaboration. Our technologies are used in collaboration of solutions such as Cloudera. So data science is really a theme that is very close to what we do. And our solutions are often used in that context. So very excited, can't wait to go sit down and attend the talk. And also, of course, very excited about our speaker today. Thanks, Amr, for being a speaker. It's a great honor to have you here. So wanted to welcome you all, introduce a little bit of TIBCO, but most of all, welcome you all, and then we can now get started. So. Thanks, and have a great evening.
Thank you. And thank you, TIBCO, for sponsoring us and hosting this event. So, just a brief introduction of the Hive think tank. So, how many of you are here for the first time? All right, welcome, welcome. And so the Hive think tank is a thought leadership forum. We have about 9,500 people who we have touched, physically touched, not Twitter followers. And those are some of our recent speakers. And so since late 2012, we've done about 170 events. And those were some of our speakers from last year, and it includes one of Amr's colleagues, Doug Cutting, out there. Thank you to our sponsors, which includes Cloudera and TIBCO, as well as Visa, SAP, Pinterest, and the law firm Perkins Coie. If you're part of a corporation such as IBM and interested in sponsoring us, please reach out to me. There's a huge number of benefits, including this awesome branding opportunity. So just a little bit about the Hive. So the Hive is a fund. It's focused on AI. It's also a studio to create companies. And so we collaborate with corporations, with founders to start companies from scratch. And typically we put $1.5 million to $2 million as seed capital and work very closely with the companies. Everything we do is an application or a use case of data science, so machine learning, deep learning. So we have a set of kind of themes that we focus on. So we're very thematic as opposed to deal flow driven. And you can see kind of a set of industries that we focus on. In addition to the Hive here in Silicon Valley, we have a separate Hive in Brazil, one in India. So I want to motivate kind of the talk of today. So you see sort of the big changes that data and AI are bringing to our lives. You see the changes in transportation and logistics, terrestrial and in some cases flying platforms that are collecting data and really a base for applications. Look at what's going on in the industrial segment, ranging from sort of connecting things for real-time operational reasons to smart machines that can self-optimize, self-heal, to completely autonomous industrial systems, to something perhaps that's going to have the most impact on you and me, which is around precision medicine and being able to sort of, based on your molecular structure or genetics, being able to sort of design healthcare, design drugs for people who are like you, as opposed to the entire population. Think about sort of the cost we can save in bringing out drugs and the efficiency with which we can come up with new drugs. And so all of this is enabled by the kind of the big change, the big revolution that our next speaker was on the forefront of, was really the changing the economics of data, changing the economics of collection of data, storage of data, processing of data, in order to be able to then apply a variety of AI and data science techniques that he'll be talking about today. And the end goal is, of course, to help assist and automate in decision making. That is the power of AI. If you're going to be tweeting today, please use the hashtag #HiveData. We'd love to hear from you. And so with that, I'd like to introduce the founder, the CTO of Cloudera. Cloudera was started by Amr in 2008, along with Mike Olson and some of his other colleagues. And Amr used to work before that at Yahoo as a vice president, where he sort of helped pioneer and bring kind of Yahoo, bring Hadoop to use within Yahoo. So he has undergraduate and I think a master's degree from Cairo and a PhD from Stanford. And all of you have probably followed sort of recent news about Cloudera. They went public, which is a really exciting thing for all of us. Congratulations, Amr and the Cloudera team. So many people stop me and ask me, tell me one company in the big data space that's doing really well. There are many companies. TIBCO is one. Cloudera is another one. And so that's an example for all of us. So the format of today's talk, we'll have Amr talk for about 45 minutes, and we'll follow that with Q&A. So please hold your questions and you'll have a chance to ask them.
Is mic working? Can you guys hear? Yeah.
The mic's not working yet.
Should be working now.
Yeah.
Okay, I need to flip over to my present, so just give me 1 second. So I'm going to do 3 things today, if PowerPoint will not crash. Okay, so I'm going to do 3 things. First, I will start by telling you a story that started 100,000 years ago. So my talk might be longer than 45 minutes. And then second, I will describe to you a problem that we had in our customer base when it comes to innovating around data science. And then I will show you a live demo of a product that we just released into general availability that's called the Cloudera Data Science Workbench that solves that problem that I will describe to you. And there will be live demos. I'm hoping the cluster actually is working back home and we can do it live. So first with the story. The mission that we're after at Cloudera, the problem that we are trying to solve, falls within what I describe as the 6th automation wave of us as humans. The first wave happened 100,000 years ago, and I don't think any of us were born back then. But that's when our ancestors figured how to talk. And talking was the beginning of the automation of transfer of knowledge. And that's really what started setting humans on a trajectory very different from apes and lions and elephants and all other animals out there, was when we figured out how to talk. So that was 100,000 years ago. And then, 10,000 years ago, was the second automation wave, and that was when we discovered how to automate the making of food. So that's the agriculture revolution. Humans were spending all their day long, 16, 18 hours, hunting, gathering to find food, and they had no time to do anything else. And when they figured out the automation of food, that's what truly freed us up to start and be more creative, and also to be able to procreate, and our population started to expand. Was with that wave. 10,000 years ago. There was 90,000 years between the first wave and the second wave. So we're so fortunate actually to be living in the time we are living in right now. Because we witnessed, some of us witnessed maybe 2 or 3 waves. The third wave, which was about 2,000 years ago, was the automation of discovery. And that was the principles of math and science coming into existence on the scientific method. And that's when we started to be able to discover things at a much quicker rate because of that. So that was the third wave. And then the fourth wave was the automation of making stuff. The automation of making stuff. And that is the industrial revolution. Right? We figured out how to use steam engines and very shortly thereafter electrical engines to make carpets, to make chairs, clothes, buildings, cars. And that, as many of you know, it actually killed so many jobs that had to be repurposed because now it was way more efficient to do that using electrical and steam engines. So that was the fourth wave. The fifth wave, and I think many of us were born during that wave, is the automation of processes. And that's the IT revolution, the information technology revolution. How do we take a process like applying for a bank account, or a process like connecting with our friends on Facebook, and doing that much more quickly and much more easily. But at the heart of it is simply a process, and we're just making the steps of that process much more streamlined, easy, and repeatable. Now, I claim that the wave we're in right now, the sixth wave, is the automation of making decisions. That's the wave we're in right now. So the wave we're in right now is how can we learn from humans for some tasks, not for all tasks, but for some tasks, how they reach their conclusions and make the decisions that they make and automate that. And that's going to be very important because going forward, our problems are continuing to explode at a much higher rate that they are surpassing our human capability to be able to fulfill them. And I'll give you some examples. So the first, of course, most popular and common one is doctors, the medical space, general practitioners. For a doctor to look at your symptoms, your temperature, your heart rate, your pulse, and tell you, you have this disease versus that disease, that problem is totally ripe to be automated with machines. And in fact, my co-founder, Zach Hammerbacher, is now part-time at Cloudera, full-time at Mount Sinai, doing exactly that. And it's not important to solve that problem just because we want to put doctors out of business. Doctors are very important. The problem is that there are not enough of them. In some countries like India and China, people can't find enough doctors for these simple things, and they end up asking their relatives, which medicine should I take? They give them bad advice that might harm them even more when it's with a very simple machine learning algorithm can give them way better advice than that. Even here in the US, when we suffer from something and we go to the emergency care, we end up sometimes waiting for 6-7 hours before a real human doctor can see us. So that's one example. How do we automate that decision so we can scale? Another example, lawyers. Sorry, is there any lawyers in the room? So apology to you ahead of time. But lawyers, they just charge too much. They charge too much. And the reason why they charge too much is because they have a very limited supply. There's a very few number of good lawyers out there, and hence that's why they can command these very, very high premiums. So one of our customers, actually that has been with us now for a very long time, JP Morgan, so JP Morgan is one of our key customers, they published a use case where for contract reviews, for reviewing legal contracts between them and other partners that they work with, they were able to train a Spark machine learning algorithm that replaced 400,000 lawyer review hours with 10 minutes of computer time. It's not just one computer, it's not one computer. But the point is, within 10 minutes, they finished what took 400,000 lawyer hours. So that's another example of how you automate the decisions by learning how the humans make them and then do them in a repeatable way. But it's not only that. In many cases, we will need to make decisions on a second-by-second basis. So one of the most interesting examples within our customer segments is in the car insurance space. So the car insurance industry is going through a significant evolution right now from the traditional way of they only charge us a premium once a month to is going to be on demand. They're going to charge us based on our actual driving behavior on a second-by-second basis. And that will change things in significant ways because now they have to assess the probability of risk in real time versus what they used to do is only assess the probability of risk once every couple of years. And historically, they used to employ a trick of we cannot do it at large scale. We don't have enough computing resources to do this cheaply at large scale. So what they did is a hack. And actually that hack was done in many industries, not just in the insurance industry. It was done in retail, it was done in banking. And that hack was, let's take all of our users, like the 10 million users, the 30 million users we have to deal with, and instead of working with them, let's map them, let's bucketize them into one of the given buckets, like married with children, married without children, this education level, that education level, this income, that income, male versus female. And then we're going to assess the probability of risk based on that. And that, as many of you know, in the data science industry know, leads to what's called false positives. So for example, my son, he is a male, obviously he's my son. But just to be specific and accurate, he is a male. And he is 20 years old, and in our house, he has the highest insurance premium. The highest insurance premium. I, on the other hand, I am male in the 40 to 50 years old range, and I have the lowest insurance premium in our house. And that is despite the fact that my son is actually a very paranoid driver. He never speeds up, he always stops at the stoplight, always uses the signals, never crosses lanes without signaling first, etc., etc. Yet he has the highest premium. I, on the other hand, and people from India can relate to this as well, but I, on the other hand, I was trained on how to drive in Cairo, Egypt. In Cairo, Egypt, if you have not been there, the stoplight is a hint. It's all about the body language of the cars around you and how you can rub shoulders with them and who's going to win the rubbing. Yes. So, needless to say, my driving behavior in the US is not the best driving behavior, yet I have the best insurance pay. Because that's the old way of doing things. The new way of doing things, which many of our customers now in the insurance space are doing, is they have a device in the car that measures how you speed up, how you slow down, how you make a turn, whether you're swerving too much, so maybe driving while you're actually sleepy or driving while you're drunk, which is extremely dangerous. And all of that can be modeled in real time to give a premium that you pay on a per second basis. So not only can we rely on humans looking at your profile once every 2 years and assessing what should be the proper insurance premium for you, we need to make a decision now in real time. So this is a very long story, but the long story is to summarize that the movement that we truly are after, all of us collectively here, not just Cloudera, is the automation of decisions. And we're not doing that because we simply want doctors and lawyers to lose their jobs. We are doing that because that is the reality of what's going to be happening in the future. We need to be able to make a lot more decisions, a lot more quicker, and free up the human brains to only focus on the most sophisticated of these decisions, as opposed to be a bottleneck for every single decision. So Cloudera, our tagline, and the marketing tagline that we actually changed recently with our IPO, is we believe that data and using data and leveraging data in the right way will make what is impossible today possible tomorrow. And I gave you a few examples of that from these stories. So moving on from that very long preamble, to our presentation today. Our presentation today is about how can we make it simpler and easier for organizations to deploy and experiment and innovate around machine learning and data science algorithms. So this is the traditional data science workflow that I'm sure many of you are familiar with. We collect our data from the different sources. We clean up, normalize, and wrangle that data into a form that we can actually work with. We run experiments and visualizations and run new models and test them to see their accuracy. A lot of them will not work, some of them will work. For the ones that work, we push them into production and we deploy them. This is the typical cycle that any data science process goes through. And the key phases to highlight in this cycle, which is where the disconnect is, which I'll talk about in a second, is the production phase, which is operational, nothing can go wrong, versus the data science exploration phase, which is about innovation and trying all the newest, most advanced, most cool algorithms out there to find how can I solve this problem in a better way. And that's where the tension comes from these two phases. So this here elaborates more on each phase and what kind of users you would see of them. The typical, here you would see data scientists and analysts. Over here you would see engineers, developers, and system engineers on the operational side. The goal here is to understand the data and build new innovative models. The goal over here, there is to maintain applications and make sure they don't break when they're running in production. And you can read through the rest of the bullet points. So that's kind of the profile of each one of these groups. And this is the problem that happened. The problem that happens is the data scientists that want to do the innovative stuff, to discover better models, they end up not having access to the machines that have the latest data that they want to be able to experiment on. They end up not having the scale in terms of computation. The scale tends to be reserved for the production systems, not for the exploration systems. And they don't have easy way to interact with the environment. So what ends up happening is a deadlock between these two organizations. You get a very bad deadlock between them, where the data scientist tells the operation guys, I want to try TensorFlow. Just taking TensorFlow as an example here. As many of you know, TensorFlow is a deep learning framework from Google. So they tell them, I would like to deploy TensorFlow on the cluster so I can try it out. And the operations guys would look back at them and tell them, no, we're not going to do that. Because we are afraid that if we deploy TensorFlow, it's going to bring down the cluster. And we're happy with things running as they are right now, because that's what we are being measured by, is the things being running in a stable production mode and meeting the SLAs. If you have a deeper conversation, if they have a deeper conversation with each other, then the operation guy will look back at the science guy and say, do you have any proof that TensorFlow is going to improve our accuracy of modeling an insurance accident, a collision, or improve our accuracy of making a certain decision? And the data science guy would tell them, no, I cannot give you that proof until you give me access to the cluster so I can draw all the data and get you the proof, right? So you get this deadlock between both groups where you just can't move forward. You can't innovate and you cannot experiment with these new techniques. And then the operators, the system operators, they're afraid of this problem. They're afraid of the dependencies of all these different packages and every group wanting their own deployment of different dependencies and projects to be able to prove out and work out the new model they want to work on, and all of the conflicts that might happen between all these modules. So that's why they push back even more when variety comes their way. So they want to push back on anything new and from a just newer version kind of thing, and push back on anything new, like a new project that they just haven't worked with before. So what happens is, the IT guys, they just want to run one thing, let's say Spark. They just want to run Spark, vanilla platform, and that's it. They don't want to try anything new. And then the data science guys, they want to go grab whatever they can get their hands on to try it and see it works. So what they did is something very dangerous. What happened now is most organizations, and maybe some of you are guilty of doing this as well, is the data scientists would deploy all the stuff on their laptop, and then they would go and copy the data from the cluster onto the laptop and run the stuff there. And take the laptop home, where it might get, God forbid, stolen or whatever. So you have a problem of security, where data now is leaking outside the organization. You have a problem of resource inefficiencies, because you're using a laptop to do what a cluster should be doing in terms of computation. And you're slowing down and putting friction between both groups in terms of how quickly can we reach a better model. So that's the problem. And that problem we have seen in our customer base over and over again, this tension between how can we be innovative and try the latest and greatest, but at the same time be stable, reliable in production. So the gap that we want to address, that we sought out to address, was to be able to talk to fill what these guys need to do, the data scientists. The data scientists tend to be the people sitting at the intersection of, you know how to work with computers and some basic programming skills, but you also have the domain knowledge and the probability and statistical skills. That's the audience that we're trying to address with this new product. So this is the product. It's called the Cloudera Data Science Workbench. It's a very long name. I did not pick that name. And the main benefits of it is having a self-service data science environment that is ready for the enterprise. So what do we mean ready for the enterprise? We mean it maintains the stability, it maintains the reliability and security that the IT operations guys need, while giving the data scientists the flexibility of going out and experimenting with any platform they would like. So how did we do that? Okay. I thought there was a slide that's missing here, but don't worry, I'll explain that in a second. So this is some of the benefits that that you get from having this environment. It's multi-tenant. You can have more than one user, more than one team, all using you at the same time. You're able to maintain lineage of the different transformations happening within the platform, and you can have different versions and dependencies of the different libraries within the platform at the same time. And one of the most important criteria that we sought to maintain while building the system is we're not going to build our own notebook, meaning a new version of the notebook where it has our own format, where you have to use our version of Python or our version of Spark or our version of R. We want it to be open, so you can use whatever language you would like to come in while deploying your IP. And that's something that always goes back to the core DNA of Cloudera. Like, one of the core aspects of what we do is enabling you as a consumer of this technology to maintain your control over the intellectual property that you built. If you built a new type of algorithms to do predictive modeling with high accuracy for collisions, for car collisions, for insurance purposes, you should know what's happening. You should know what the model is and how to rebuild it and how to tune it. As opposed to getting a black box approach, I'm going to name them out publicly, like IBM Watson, where IBM Watson says, give us all the data, and then we'll give you back the results of that data, and you have no idea what's happening inside. I want to know what's happening inside because I want to, that's my differentiation. If that thing happening inside becomes a commodity that any other insurance company can do, then what differentiates me, and how can I be a long-term successful competitor in the future? So one of the key things that we maintain while doing this is this openness of using whatever you would like within the environment. So now, before I jump into the demo, briefly, how do we achieve this? How do we do this within our platform? Meaning fulfilling the requirements of the IT operations guys of being stable, reliable, and not having to manage all the dependencies, and the data scientists of being flexible and being able to try the latest and greatest. And the way that we solve that problem is Docker. So you know Docker containers? And what we do is in front of the main Cloudera cluster, we instantiate a gateway cluster, 4, 5, 6 nodes. It doesn't have to be very big. And that gateway cluster is running Kubernetes. And then inside Kubernetes, we have Docker containers for each one of the data scientists. And inside of that container, they can deploy whatever library they would like, whatever version of Python they would like, the new TensorFlow, etc., etc. And that's how we appeal to the best of both worlds. These containers, while they're running in that gateway environment, they are fully instrumented and tracked from a lineage point of view. The data never leaves the cluster. The data stays in the cluster. and they're also fully tracked from a security and authentication point of view, so solve that problem. These environments, because they are Docker container, they're fully isolated from each other, so each one of us can have our own versions of the different libraries that we use without affecting the main stability of the main cluster. So one way to think about it is the way we solve the problem is by going the laptop approach. So we looked at the laptop thing that our users were doing. Instead of you having to run this in a laptop, you just run that laptop in a container. And this way we can keep that container within the cluster environment. It can still have access to all of the original data with high fidelity. And we can maintain the lineage and the access control at the same time. I don't know why the mic is here. But that's how we solve it, it's Docker container. So with that said, I'm going to now start doing a live demo, and I'm crossing my fingers, everything will work fine. Hopefully it should. I did test a number of times before the talk. I'm going to move the table a little bit. So I'm facing you guys still. As far as it goes. Yes, so this is the main environment. I'm actually going to go back to my main account page. Can I? Oh. How do we resolve this? I move this to the other screen and then I'm going to see it. Yeah, I'll do the mirror thing. Okay. Cool. Thanks for doing that. That's okay, so this is, you guys can see this now? I can try and make the fonts a bit bigger. Let's see. This clear? Focus on the back, okay. Good. So this is what the environment looks like. It's a web-based environment. It's, you can think about it is like a notepad, but the notepad has all this integration with the Docker Kubernetes cluster on the back end. So you have different users. The users can have projects. You can have teams, and the users can be parts of teams or not. So up here you can see I have other contexts I can switch in to operate as one of my teams as opposed to myself. One of the key things in the account settings here, just to show you very quickly, is the Hadoop authentication thing, which is this is usually a nightmare to get the Kubernetes thing working with all the authentication done with the backend cluster. And we take care of that. We do that within the environment itself. Of course, between CH and the Data Science Workbench, because we control the whole thing end to end. So now what I'm going to do is show you a specific project. First, I want to show you how to create a new project and how easy it is. So if I go to new project here, I can simply just say the project name, my project. I can decide whether I want to share this with others or not, private versus public. And then down here, you have a number of ways with which to do it. The two most popular that we have seen right now with our customers are local, where they just take a bunch of pre-existing Python files or R files and just upload all these files as is. Because we work with them as is. We don't require any special format for our environment. Or similarly, you can connect to GitHub and fetch in your projects from GitHub. So I'm not going to create a new project right now, but I just wanted to show you how that looks like. So now if I go to one of the demos, let's do the short demo, this one here. So I have 3 demos here. I'm going to show you the Python one and the TensorFlow one. So this is a Python demo. If I click on the Python, you can see the Python code here. Just opening the code up in the browser. And then what I'm going to do now is I'm going to create the container now. I'm going to create the container with my project, opening Workbench. And that's what this is happening right now. So now it's deploying, asking me to how to configure that Workbench environment. So I'm going to say I want Python 2 for this Workbench. And you can decide how big of an instance you want. So 4 CPUs, 8 CPUs, so depending on what you're trying to do inside of that laptop, that Docker container. I'm going to pick 4 CPUs, 8 gigs of memory. I'm going to launch my session. So now what's doing is it's creating a Docker container, and then it's deploying that Docker container in the gateway environment in front of the main cluster. So that's what's happening right now. This color should switch from red to green as soon as that is done. And it's done. So now I have a live node, gateway node, connected to the cluster to work with. So for example, I can go here in this session and I can start typing Python. I can do 1 + 1. I want to see if I can remember how to do a for loop. I equals 10. Is it right? Is it right? Any Python developers in the crowd? Yeah. This looks right. Yeah, there you go. So you can just run Python, and so it's all running in the browser. You can, if you want to get a shell session into your Docker container, you can click on Terminal Access up here, and that will give you a shell session into the container. I'm going to increase the font a bit. So now this is my connector into that container, and I can look at the files. So I can do NSLA, you can see which files are in there. So I can maximize this. NSLA, so you can see the files. I can do pip list to see what packages are deployed within my Python environments. I can do pip search H2O to see if I have the H2O libraries deployed, and I can pip install them if they were not there. So the idea is you have full access to this container, and within that container you can do whatever you like. It's fully yours. So now, once you have this environment set up, you have your Python, and you want to try it out, you can click run here. We have 2 options. We can run it line by line, or we can run everything. So I'm going to hide the code now so you can focus more on the environment. So you can see it running here, and again switch to green, so finish running. So what this Python script is doing some predictive modeling for the Dow Jones index, and whether to buy or short stocks based on the volume. And yeah, you can, as you can see, you can embed charts, you can embed everything you can do in Python, you can do within the Notepad environment. And it will show you the code while it's executing with the output of that code. If you want to share this with somebody else, it's very easy. You just go to the share link here. You want to collaborate with somebody else, you can. There's 2 ways to collaborate. You can collaborate just to show them the output, so that you just can see the output, which is what I'm doing right now. So when I take this link, and if I paste this link, or I can put it in email or whatever, send the link, it will render out a live version of the output of that Docker container model that you built, including the stuff I did at the beginning, by the way. So now if you go and change any of the underlying data, this output will change, because every time they go to that thing, it actually reruns the Docker container just for that consumer. And if you don't want them to see the code, you only want to see the output, you can do collapse. If you do collapse up here, collapse just hides the code, only shows you the remarks that you have in your Python notepad and the output from the script itself. Make sense? That's for sharing for viewing. If you want to share for collaboration, then you can share the actual project itself. So you can share the actual Docker container itself. And the nice thing in this case is, if you were collaborating with another scientist and you simply send them this script on the left side, this Python script, they will not be able to run the Python script until they go and install all the libraries and everything else you depended on. But in this model, when you're actually sharing the full environment with them, with all the dependencies, with all the code and libraries it needs. So they're able to start working on this right away. So that's the main things I wanted to cover with Python, and then I'll show you TensorFlow. I just want to make sure I cover most of yeah. So now I'll show you the TensorFlow example. Oops. Let me close my. I didn't close my TensorFlow. Anyway, if I go back to projects, then I can move over to the TensorFlow. So I have another Docker container where I deploy the requirements for TensorFlow. And this is a Python interface in TensorFlow. So I'm going to pick Python. I'm going to pick, let's make it bigger now because TensorFlow is a bit more resource intensive. So 8 vCPUs, launch session. It's now creating the session, and then I'm going to run it. So this is a very popular TensorFlow kind of demo that looks at recognizing digits like 0, 1, 2, 3, 4, 5, and so on, and creates the weight maps. So it creates a weight map for each visit based on learning from the underlying data, so that blue means red is positive, reinforces the weight, and blue is negative. And you'll understand what I mean once I show you this in a second. So now I'm going to start the TensorFlow job. So run all lines. You can run line by line if you want to run. So this is actually going over a large training set and it's generating these weight maps that are coming out of TensorFlow deep learning model that you can now then deploy in production. So it's done now. So essentially what these weight maps, again, any of you familiar with the MNIST, it's like the hello world of TensorFlow. This is a 0, so you can see the blue here means if you have pixels that overlap with the blue area, then you get positive weight. If you have pixels that overlap with the negative area in your drawing, then a negative weight. So hence, this will have the highest probability will be in the 0. This is what the 1 looks like. This is what the 2 looks like. So the blue here roughly is the 2, and the red here analyzes you. If we move on to the 8, there's another interesting one. So you can see the 8 here, you can see the blue around the 8, that reinforces, and then all of these gives you a negative score if you overlap with. So that's the output of TensorFlow. Now the beauty of this, it's like, what are you doing? This is normal, like you just ran TensorFlow thing. The beauty of this is I ran this on the environment without having my cluster admin telling me no. But with my cluster admin having the ability, the full lineage, the ability to see which data I accessed that fed into this environment, and which version I was running, and whether I failed or not. So they can see all these things. So this way you can break this deadlock between your data scientist and the operator. Now when the operator says, can you prove to me that this new model is going to be better than what we have, to justify me taking the risk of deploying this in production, you can tell them, yes, here is the proof. Send them the link to the outputs, and this shows you that our efficiency now is up by this much, and then they can go and look. We have this other color code Cloudera navigator that shows you the lineage of where they come from and how stable you were during that run, and they can put to themselves, okay, this actually now worth investigating to promote this to be part of our main cluster environments and not just inside of the Docker container. So it helps you solve that issue. Now some other simple features, and I'm almost done, and then we can open up for Q&A, is all of these sessions, everything that you run is being tracked in sessions, so you can go back to any previous session you have. So you can see here I have 2 running sessions that I ran with you right now, they're still running, and I can go back to them, jump back into that session, see the workbench for that session, and how is it performing, change anything in it. And if you don't kill them, they actually, you can set up for the cluster, auto kills sessions. If they're not running anything, then eventually it auto kills them. If I go back to the overview view here, it shows you for the overall environment, it shows me here that these green things are these CPUs that I am allocating for myself, running with my containers. And the bigger one is the total cluster, so apparently everybody at Cloudera is back home. Nothing else is running in the cluster right now except a few up here. So that you can see the consumption from here, and the system will automatically garbage collect sessions that are not being used. Another simple way to schedule jobs. So we have that as well. It's not like the most advanced job scheduler, but it's a nice simple way to schedule jobs, meaning things that run at any given time. So if you want to do a recurring job that runs over and over again.
Production of this modeling, or just after you secure discovery
that is a very good question. You might hold into that, I'll answer that right after this. So it's an excellent, we'll start with that question. It's a very good question. So if I say new job, then you can say the name of the job, the name of the script that is going to, pick which script is going to run whenever it's running. So I'll pick, for example, my Python script. Which version of Python to run within that environment. And then in schedule, you have 3 choices. Manual means you just trigger it yourself, recurring at any given time, or you can do dependent, where it runs as a function of another job. I don't have another job defined here, but you can say when that other job finishes and the output is ready, then start my job. So you can do this simple scheduling of the jobs to run within the environment. Again, these are still all running within your exploration environment, not the production environment. And I think that's most of the things I wanted to cover. Yeah, that's most of the things that I want to cover. So now we can open it up for Q&A. So we'll start by taking the first question. Maybe you can repeat the question again, and then.
So the question was how actually you move to production. That's obviously the challenging part usually, how to make it happen. And you mentioned about the life cycle. So have you added any features to actually make it easy? Because obviously a Python script, it's not directly movable in most cases to any like high production workload distributed environment. So that's kind of my question.
Yeah, so the main thing we want to solve in this version, in this first iteration, is breaking this deadlock between the production team and the science team. Giving the data science team the ability to show evidence that their algorithm is getting better performance, to justify the operations teams deploying this version of Python or this version of Scala or whatever. The idea is still it will deploy that. Actually, we have customers deploying Python in production. So I wouldn't say Python is not a production-ready language. It's more about, do you have the proper source control behind it so you can roll back if you need to roll back? Do you have the proper lineage behind it so you can see which data attacks and which data generates on the other outputs when it finishes, and all these kind of things. That's what the production folks need. Now, the Nirvana, the ideal environment would be this demo, as I showed you. Once you finish scheduling that job within your own play area, which is the small Kubernetes cluster that we create for Data Science Workbench, I will take that job now and deploy it within the main environment and make that as part of the overall flow. Like the system admin or the operations guys can come in, they can look at it within the play area and say, this looks perfect. Now let's take this as is now and migrate it to work in the main area. That is to happen, which is a very hard part, you guys. But yes, our plan is absolutely to solve that problem as well. The idea is to go back to the flow I showed you at the beginning and make that flow as easy as possible to go through the full cycle from exploration to deployment. So, very good question. Thanks for asking. Yes, you're right. We need it. That's true. There's another question over here.
Thank you for the presentation. I don't know if you mentioned, can we choose GPUs?
Not yet. So today, in the Cloudera environment, we don't directly support GPUs. We have customers that hacked our environment to support GPUs, but it's not directly supported targets right now. But it will happen. I mean, it is in the roadmap, so it will come at some point. I cannot tell you when, but it is in the works. Yeah. Other questions?
Hi, thanks for the talk. What are the distinguishing features of this data science workbench compared to like a Jupyter notebook server?
Very good question. So the key, which is, I think this actually slide speaks to that question, which is what is the key things that differentiate this from like Jupyter or IPython or whatever, Zeppelin. There's a bunch of these notepad environments out there. And the main difference here is the enterprise readiness, that this plugs in directly into the main cluster environment with the access to the original data, with proper authentication and access control and auditing and lineage. So that's kind of the main thing. It's not just an offshoot thing that you're running on the side, it's a part of the main environment, blessed by the IT team. Yeah. And it's compatible with these notepads. So you can take a Jupyter notepad and load it into here and it will run as is. Yeah, I mean, fully secured is the main thing. Support multiple languages, so not just Python. So other languages are supported. Multi-tenant, you can have more than one user within the platform, and then work on the original data as opposed to a copy of everything. Yeah.
So how do you handle the scalability part? Let's say you were mentioning you just use one Docker container to run the code. Let's say, you know, my data pipe needs in 10 a cluster of like 10 machines and 10 Dockers. I mean, how do you kind of control that at all?
So the control.
Let's say as data scientist,
Yes.
I have like usually one of the problems that you can see is like, oh sorry, there's sort of like a scale. You know, how do you kind of like distribute across the cluster? You know, and that's why the part say, they might not have controls, like, I only have, it seems like you have only one Docker container. Let's say I have...
No, you can have more than one. So
okay.
In this session I had 2 running. You can have more than one Docker container. There is a certain number of Docker containers. Like in this cluster environment, we have 80. There is 80 maximum of 80 Docker containers that could be simultaneously running. And it will show you, the visualization shows you, this is how many of the 80 you're consuming right now. So you should collaborate together and figure out, avoid overloading the system. And the admin can come in and they can kill some of the containers that are using the system. So we have all of these kind of capabilities around managing the containers. Within that, playground environments, not the main.
So does the data scientist himself can pick and say, I need, by my job, I need like 80 containers to run fully?
Oh, no. So I need to clarify this. The container you're running is simply the laptop. It's the gateway. The actual code is being executed within yarn in the cluster itself. So that gateway, I'm coming in, if I have a Python Spark job, and I'm going to write my Python Spark job, which is going to go in my container, but then when that job starts to run, the actual heavy lifting is going to be pushed to run in the whole environment itself, not within your container. Your container is simply the gateway into the cluster. So you are taking advantage of the full cluster resources, but you're only allocating one container to yourself. The only exception is if you install something new like TensorFlow, which is not in the cluster and it's only within your container, then it's only going to run within your container. It's not going to run in parallel across the cluster. That's the only exception. But other than that, if you're using Vanilla Spark or using any of the other deployed environments within the cluster, then it will run in parallel and it only there as the gateway. Okay?
Thank you.
Before and while the next question is being queued up, raise your hand and the mic will come to you. I wanted to briefly mention this event that's coming up. It's one of the most widely attended hardcore data science events in the Bay Area, and actually we're doing it across the world now in a number of other locations. So it's coming up on July 20th, and it's going to be in San Francisco. It's called Wrangle, is the name of the conference, and you can find more information about it here. I think the call for talks is done for it already, right? So we already have talks lined up, great agenda for the event, so I just want to mention that briefly. Other questions?
Yeah. So you mentioned that the code is actually running in the cluster.
Yes.
And by cluster, you mean the containers that have 8 CPUs, or you mean the Hadoop cluster?
The Hadoop cluster, the Hadoop / Spark, the CDH cluster, right? So you have the CDH cluster, which has Hadoop, Spark, Impala, and many other things.
Right.
Edgebase, you name it, like all the things we have. So you can have like 300, 400 nodes of that. And then you have 5 nodes, which are your gateway clustered into that cluster, right? So when I deploy my Docker container with my Spark job, it's going to start first inside of the gateway, but as that Spark job now starts to make calls into Spark, then that will run in parallel in the cluster itself.
I see. And how does the container interface with the cluster? How the data gets...
Yeah, we do Kerberos. It's simply connecting over Kerberos and submitting the code using the standard Spark / MapReduce / whatever APIs.
I see. And would it support some graphical UI in the future, or does it already support?
It supports any of the graphical extensions that you already have for notebook environments within Python. Like I showed you some graphs already embedded within the Notepad as I was running the demo. I don't know if you noticed that or not.
Yeah, I missed that one.
Yeah.
How about Tableau? Can I?
So that's different now. So for Tableau, what you can do right now is simply write the files out and then load them up into Tableau. There's no direct connection with Tableau right now. But that said, Tableau is more for SQL usage as opposed to for Spark and R. So we have integration with Tableau, direct integration with Tableau on the Impala side. So Impala is our SQL engine. That one feeds into Tableau directly. But that's very different from this. This is really about running a more advanced machine learning data science algorithms.
So one last question.
Sure.
So the Hadoop cluster or the Spark cluster or the CDH cluster,
yes.
So it runs in AWS or Google Cloud, or it runs in your own cloud?
Oh, thank you. That's actually a very good question. I love that question. So our name is Cloudera. And I'll actually tell you a very quick story. We have a hand over here, so maybe the mic can move over there while I tell that story. Our name is Cloudera because in 2008, when we were starting this company, we went to the investors and we told our investors we want to start a cloud company where our customers upload all of their data to our cloud and they do their machine learning, their AI, and they download the results. And our investors believed in that pitch and they gave us money. But then when we went to talk to a big bank like JP Morgan was one of our very first customers, and we talked to the US government, all of them back then in 2008 said, no way we're going to give you our data, forget about it. So we had to pivot the company, actually, a small pivot, to be a distribution that can be deployed on-premise as opposed to cloud. But then about 3 years ago, a big shift started happening within our customer base where they become more comfortable having some of their data, not just their front-end web servers and mobile apps, but their core data also be in the cloud, the back office data. And that's when we shifted our platform to run both as an on-premise or in cloud. So today, about 18% of our customers are running workloads in the cloud. So our platform works as both options. And within the cloud, we have both the infrastructure as a service option, where you're running a permanent cluster, you're always running that cluster. But then we also have a platform as a service offering where you can run the cluster, scale it up, scale it down on a per job basis, as opposed to always on knowledge. So thanks for that feeding question. That was the long story. The short answer is yes, we support cloud. That's the short answer.
Hi, this is Greg. What's the communication between Docker images? Let's say I have one Docker image that I put out that's going to be very low latency, fast scoring of records. And then another Docker image is for periodically retraining models, very long latency, but then once it retrains the model, it's finished, and I want it to update the scoring system. And then, so how would that work?
So again, this environment is not intended for low latency production serving. It's not intended for that. It will not achieve the low latencies you would expect because of all the overheads and the way that it's set up right now. That said, you can create jobs and dependent jobs. Like actually, I'll show you very briefly an example of that. So I go back here, and I go back to.
So nothing with Kafka streaming.
No. But you can maybe you can connect through Kafka. Right now it's through the file system. So right now you write to HDFS and you pick up back up from HDFS. So if I show you this feather demo, if I go to the jobs, oh, sorry. Oh, I have to do something. Sorry about that. Okay, that's not right. I just killed it. That work? There you go. Yes. So this shows you the dependencies. So in this demo here, write feather is writing out the frame that read feather is reading in, and that job, the read feather job, will only get executed when write is done and the file is written out in the place. But the communication mechanism is through HDFS right now, not directly through Kafka. So again, this is all about exploration. It's not about production.
Okay, so you don't put your production models. You don't put your models into production.
No, you're putting them in exploration mode, production exploration mode for you to internally make sure they're working.
I'll say, so if I want to build models, I can use what's closer to the production environment.
Yes.
But then
at the end, you still have to give the code to the production guy to say, deploy this in the main environment now.
But I give them a Docker image to go to production or what?
Yes, you give them Docker image.
Okay, so when that Docker image is running, it's still not low latency.
They will not run the Docker image. They will parse out the Docker image to figure out the dependencies you need from a library's perspective and go and deploy that. They actually don't define Docker image as is.
Okay.
And that is exactly the question that was asked at the beginning. And that's Nirvana. Like, that is Nirvana. If you can take that and deploy production right away, that's exactly what we want, but that's a very hard problem to solve.
Yeah, it is. Okay. Any kind of once and only once guarantee of transaction processing, or I guess this is all the exploration, so that doesn't really come up.
No, so transaction processing is a different world. It's part of our system, but that's not this world. That's more about Hadoop, so the Hadoop storage system, which maybe at some point in the future we can do our separate session on Hadoop. But Hadoop is a new storage system that just went GA a couple of months ago, and Hadoop is about supporting transactions in real time while you're doing Spark runs on top of Hadoop. So when you're doing analytics or doing SQL, you can have transactions happening at the same time. And that's really what Hadoop is about. So asset. It is asset. It is asset compliant transactions, but I need to highlight, the question is whether it's asset compliant or not. It is asset compliant, meaning it's atomic, consistent, isolated, durable, but only at the row level. So you cannot say begin transaction and then do a bunch of stuff and then end transaction. No, it's for any single row, you can have multiple clients and you will maintain consistency. Yeah. So last question?
Oh, thank you very much for sharing your knowledge and demo project. This is very interesting. So I'm a front-end developer, so I was thinking about continue with his question about the dependency of the jobs and also the communication between the containers themselves, because I was thinking some of the code we focus on the open source ecosystem, but we want to make some of the code reusable. Some of the code we deploy, it doesn't change much. For example, they always use the same build system, like front end, and like Node.js or other open source library. And once your data comes out, how you funnel those results, go reuse some of the project from the visualization and render them.
Yeah. So again, today, for this environment, the way for the outputs of the jobs to be fed into other jobs is all through the file system, through HDFS. When the job finishes, it writes out a file that then gets picked up by another job within the system or by a job outside the system. That's the communication mechanism that we have today. And you're right that to make that easier to deploy in production, it would be nice to also have a REST API that you can connect to. It would be nice to have a Kafka topic that you can subscribe to, from which you can pick out the outputs. So that's coming, that's not there yet. But our goal is to solve that problem in the longer term as well. Again, we just released this product literally like a week ago. So I love the feedback and we'll get there, but this is really right off the presses. Hot off the presses. So that I'd like to thank you very much for being here today.
Thank you, Amr, and thank you to this great audience for all the questions, and thank you, TIPCO, for hosting us today. Sit around and